Okay, today we're going to be doing integration by substitution. So we know the chain rule in differentiation is dy by dx is dy by du times du by dx, where we're using some substitution that we've used in to convert an equation that's really quite difficult into something that's more manageable. So integration by substitution is the opposite. It's the opposite of the chain rule. And we can, if we can find a simple substitution for something that's really quite complex, we can make the integral easier and therefore do it. So to be able to see how this works, let's go and do some examples. Some of these are quite tricky and you just need to be quite careful as you work your way through them. So we're going to use the substitution u equals 2x plus 1, and we're going to use it to integrate 4x the square root of 2x plus 1 dx. Now we're going to put this into the version, so we have the x's are going to be replaced by u's, but we can't differentiate with respect to x, we're going to have to differentiate with respect to u. So let's find out what du would, what the, let's differentiate this first, and we'll get 2. So this then gives us dx equals du over 2. So we can substitute the dx for du over 2. Now, secondly, we'll be putting 2x plus 1 will be replacing by the u, so we'll have the square root of 2u, but we've got an x here. We can't have an x here when we're integrating with respect to u, not x. So what is the value for x? So we have u equals 2x plus 1, and we can rearrange that to give us x equals u minus 1 over 2. So now we're going to substitute all these different components in. So we have 4, and we have u minus 1 over 2, and then the square root of u, and then du over 2. So let's now tidy this up before we do anything. These are going to cancel. We've got a 2 times 2, that's 4, and 4 there, that will all cancel out. Then we'll have u minus 1 multiplied by u to the power a half. So, and that's by du. So that then becomes u to the power 1 and u to the half. They add the indices together to get u to the 3 over 2 minus u to the power half du. And now we just integrate that. So this will be 2 over 5 u to the 5 over 2 minus u to the 2 over 3 u to the 3 over 2 plus our constant of integration. Now we need to substitute back in for x. So this will give us 2 over 5 2x plus 1 to the 5 over 2 minus 2 over 3 2x plus 1 to the 3 over 2 plus c. And just leave it like that, we can't make that any simpler than what we already have. So let's do another one. So this time we're going to use x equals 2 tan u as our substitution, and we're going to integrate 8 over x squared plus 4 dx. So this is an x squared, so we're going to find what x squared will be. It'll be 4 tan squared u. And we also need to find out what dx by du is. So that would be 2 sec squared u. So dx becomes 2 sec squared u du. Now we're going to substitute these into our integral. So we have our 8 and we have 4 tan squared u plus 4, and then we have 2 sec squared u du. Now if we remember, tan squared u plus 1 equals sec squared u. So when you're doing ones with when you're using trigonomic identities, remember, always have in your mind the different toolkit that you have, all these different identities that you can pull on and do substitutions with to make things easier. So let us, so this is going to be, we'll take this here, this will give us 16 sec squared u over, and we take our 4 out here, so we'd have 4 tan squared u plus 1 from this, so we can then substitute that in here. So now we've got 4 sec squared u du. Now we can simplify this even more. The sec squareds will cancel out. 16 divided by 4 is just 4 du. So something that was quite messy and a substitution that didn't look, it looked a bit bizarre that we choose that, has suddenly come down to just be 4, which is very easy to integrate. So we just get 4u plus c. Substitute back in for u. Now let's think x was 2 tan u, so x over 2 equals tan u, so u must be the inverse tan of x over 2. So it's going to be 4, the inverse tan of x over 2 plus c. Now again, on the similar lines, we're going to use trigonomic identities again. So this time our substitution is going to be sine x, and our integral is going to be sine squared 2x cos x dx. Now we heads up. You've got a 2x here and you've got an x here. Think about double angle formulae. When you see that, there's a high probability you're going to have to pull on the identities for double angle formulae. Right, so let's go back to our substitution. We'll differentiate it. Du by dx is going to be cos x, and dx is therefore going to be du over cos x. And let's now think about sine 2x equals, it's our double angle formulae, so 2 sine x cos x. But this is squared, so if we were to square this, we're just going to square that, and then we get 4 sine squared x cos squared x. Now, u is sine x, so we can put 4 u squared. Now cos x, we can use the identity where it's going to be 1 minus u. Oh, that needs to be squared. There. Because remember, Sine squared x plus cos squared x equals 1. So just rearranging that, we can change that there. So where does this take us? We now need to change our integral. So we've got sine squared sine squared x is this, which we made into this. So we've got 4u squared 1 minus u squared 1 minus x 1 minus u to the power squared, and then du is going to be, and we've got cos x, and then the x dx is du over cos x, so these cancel out, and then we can tidy this up and get 4u squared minus 4u to the power of 4 if you substitute and tighten and open brackets, etc. And that's all du, and that's a nice easy thing for us to integrate. So that's going to give us 4 over 3u cubed minus 4 over 5u to the power 5 plus c, and we substitute back in for our value of u, so it's going to be 4 over 3 sine cubed x minus 4 over 5 sine to the power 5 x plus c. Now, definite integrals. You must convert the limits for u. I'll show you what this means. So we're going to use the substitution u equals x plus 1 to integrate the following between 0 and 3 of x over square root of x plus 1 dx. So again, we need to find a value of x is going to be u minus 1, and du by dx gives us 1, so that therefore means du equals dx. But if x equals 3, then that means u equals 3 plus 1, which is 4. And when x equals 0, u equals 1. So let's substitute everything. So now we've got the limit between u equals 1 and u equals 4. Our value of x is u minus 1 over the square root of u du. And we can tidy this up a bit more. So between 1 and 4 of u minus 1, u to the half du. So we'll expand this out, which will give us 1 to 4 u to 1. Well, it's minus a half, sorry. It's going to be a half minus u to the minus half. Oops, du. Which gives us 2 over 3 u to the 3 over 2 minus 2 u to the half between 1 and 4. Substituting that in, we get 16 over 3 minus 4 minus 2 over 3 minus 2, which equals 8 over 3. So I hope that helps.